Let's take a look at the answers for exam 1X. Question 1, we have a graph of a function. We want to find the limits as x goes to 3. The first one is x goes to 3 from the right. So you see I'm tracing, and we end up at y equals 2. Part B is from the left, and that is also y equals 2. Since the left and right limits are the same, then the full limit is also 2. For the function value, though, we have a solid dot above here, and so the y value there is 4. Since the function value is not the same as the limit, the function is not continuous at x equals 3. The reason is the limit as x goes to 3 of f of x is, f of x is not equal to f of 3. So in order for a function to be continuous, the limit must exist, the function value must exist, and both of those must be the same value. Question 2, draw a graph of a function that meets these conditions if possible. So the first one here is the limit as x goes to 1 from the right has a value of 3, and the limit as x goes to 1 from the left has a value of -1. So here we just have 1 on the x-axis, and from the right side we need it to be at 3. It could be a whole or a solid, and it just comes into that from the right side. And then as we come in from the left, it needs to be down here at -1. It's not quite to scale, but that's all right. Pretty close. And so from the left, it comes into -1. Now, either one of these holes could be the solid, or they could just be holes. We're just looking for the graph behavior that leads into x equals 1. So something like that. B, draw a graph of this function. So the limit as x goes to 2 from the right side goes to positive infinity, and the limit as x goes to infinity of the function is equal to 3. So this first limit is referring to a vertical asymptote, at least on the right side of -2. The limit as x goes to infinity refers to the horizontal asymptote. So we could have this function here. As x goes to -2, we could have a vertical asymptote, and on the right side, it goes up to positive infinity. And then, as x goes to infinity, we get a horizontal asymptote. So the rest at 3. So the rest of the function could, do something like this. But it needs to settle in on 3 as it goes out to the right. And then there could be some other stuff on the other side here. It doesn't matter. It could be down here. The left side, nobody knows what that does because this limit just says as x goes to positive infinity. So we don't know. But you had to have these two critical points here, or parts at least, here and here. Let's take a look at problem 3. And this was the section where you had to find these limits. So the first one, there's no problem. We just evaluate this limit by plugging in the number. So it's 7 times 5 minus 8. 35 minus 8 is 27. For number 4, if you try to evaluate it, you'll get 0 over 0. So that tells us we need to try to factor. So we're going to get x minus 9 and x minus 4 over x minus 9 and x plus 9. If you then cancel the x minus 9s, you're actually canceling the term that created the zeros, and that leaves you with the limit as x goes to 9 of x minus 4 over x plus 9. And there's no problem with evaluating this limit by plugging in the number. So that would be 5 over 18. In problem 5, we're looking for the limit as x goes to 3 from the right. So we need to interpret the absolute value if we are using numbers from the right side of 3. If the x is on the right side of the 3, then that means they're bigger than 3, and so x minus 3 is a positive number already. So this is x minus 3, and we simply remove the absolute value bars because x minus 3 is a positive quantity already. X minus 3 over x minus 3 is a 1, and you take the limit of a constant and you just get 1. On problem 6, we have a piecewise function, and we're finding the limit as x goes to -2 from the right. So since we're taking the limit as x goes to 2 from the right, that means the x values are greater than -2. Well, that refers to the top function and the top function alone. So the limit as x goes to -2 from the right of f of x, so I'm writing it in general with f of x, but since I'm doing the right limit, I know which expression to use, and that's 5x plus 4. And there's no problem with plugging in, no problem with plugging in the value here. So it'll be 5 times -2 plus 4 is equal to -6. Notice that you do not use the second piece of the piecewise function at all. It's because you're taking the limit as x goes to 2 from the right. So the bottom piecewise part of the function doesn't play any part in this problem. Problem 7 is the limit as x goes to infinity of this rational function. Again, the limit as x goes to infinity is referring to the horizontal asymptote or end behavior if it exists. Here we'll use our rules that we talked about in class. We look at the degree of the numerator and the degree of the denominator. Here those degrees are the same, so the answer is the ratio of the lead coefficients. We're looking for the exact answer, 5 over 7. Question 8. Find the intervals where q of x is equal to x squared minus 1 is continuous. Well, this function is a polynomial, and polynomials are continuous over the entire real line. -infinity to infinity. Question 9. Let p of x be x squared minus 4 over 2x squared plus 5x plus 2. Find all the partition points of p and then create the sign chart for p. So to find the partition points, we need to take the rational function of p and find the zeros and where it's discontinuous. You find the zeros by setting the numerator equal to 0. So that would be plus or minus 2. And the discontinuities by finding where the denominator has zeros. This one factors as 2x plus 1 and x plus 2. Set each of these equal to 0 and solve, and you get x is equal to -1/2 and x is equal to -2. Now something you should note here, if I write out the zeros as 2 and -2, notice that we got a -2 for both the zeros and the discontinuities. Being a discontinuity overrides being a 0. So there are 2 discontinuities and only 1 0. Now let's create the sign chart. And we need to list these points in order. And so that's -2, -1/2, and 2. And then you test points in the middle of these intervals to see if they're positive or negative. And we had positive, positive, negative, and positive. We also need to mark whether or not these points were discontinuities or zeros. The -2 was a discontinuity, so we put ND above it for not defined. Same thing for -1/2. And then the 2 was a 0. Now we'll need this information later to determine where the function f is continuous. But this is the completion of the sign chart for p. Now finally, we want to know where f is continuous. So f is continuous because it's a square root function, and please note that f of x is actually just the square root of the p function. That's on purpose, because you're going to use the information about p to figure out f. So f is continuous where p is continuous and positive or 0. So we need to find the regions where it's positive. So that would be this interval here. I'll shade it in green here. And then it skips over -2 because that's a point where it's undefined. And then we have positive between -2 and -1. But then again, we have an open circle at I'm sorry, -1/2. We have an open circle at -1/2 because it was undefined there. And then we have positive here from 2 out to infinity. However, notice that at x equals 2, it's a 0. So that one does work because you can take the square root of 0. Square root of 0 is 0. So with that, we have the following area and intervals of continuity. -infinity to -2, union -2 to -1/2, union 2 to infinity. And technically it should be a bracket at 2, but I didn't take off points if you didn't put the bracket there. But technically it should be because it should include the 0 at that point. Let's take a look at problem 10. Determine where the function f of x is equal to x cubed minus 5x squared over x squared minus 25 has vertical asymptotes and where it has holes. So first off, I will factor both the numerator and the denominator of f. Next, we know that the vertical asymptotes and the holes come from the discontinuities of the function. So we only need to set the denominator equal to 0 and solve. So we get x is equal to 5 and x is equal to -5. We do not worry about the roots because the roots would come from the numerator and they would not lead us to vertical asymptotes or holes. Next, we're going to use our rule to determine whether or not we have a vertical asymptote or whether or not we need to further check to see if we have a vertical asymptote or a hole. That rule is you look to see if you have the factor of the 0 from the denominator, the discontinuity, in both the top and the bottom. So let me start with x is equal to -5. The factor that creates x is equal to -5 is x plus 5. There is no x plus 5 in the numerator. And so that tells me that x is equal to -5 is in fact a vertical asymptote. Next, let's look at x is equal to 5. The factor that created the discontinuity of x equals 5 is x minus 5. But there is also an x minus 5 factor in the numerator. So we need to take the limit. So because there is a factor in both the top and the bottom, we do not immediately know whether or not it is a vertical asymptote or a hole. So the trick here is to take the limit as x goes to that number. When you take this limit, notice that these factors cancel. Leaving me with the limit as x goes to 5 of x squared over x plus 5. That gives me 5 squared over 5 plus 5, which is equal to 25 over 10, which reduces to 5/2. Since you took the limit as x goes to 5 and you received a finite number, in other words, no infinities and no does not exist, it's an actual number, then that tells me we have a hole. And the hole is at 5, 5/2. And to answer this properly, you need to give both the x and y coordinate. And you find the y coordinate by taking the limit. The limit is very important in this problem. Let's take a look at problem 11. So we have a question about first class postage. It costs 50 cents for the first ounce or fraction thereof, and then an additional 30 cents for each ounce or fraction thereof. So we'll let C of x represent the cost of the postage for a letter weighing x ounces. So to write the piecewise function, it'll be C of x is equal to, and then you have this big brace here. And then we're going to have the function values here, and then the domain area on the right. So many of you misplaced where the domain part goes and where the values go. We need to get the piecewise function format correct. The domain values go on the right side, the function values go on the left. So here's the first one. It costs 50 cents for the first ounce. Now the first ounce is when the weight of the letter is between 0 and 1 ounces. And then fraction thereof. So if it's a fraction of the first ounce, like it's a half an ounce, then that still counts for the 50 cents. Then you're going to add an additional 30 cents for each additional ounce going over. So it's going to be from 1 to 2, including 2, another 30 cents, and then another 30 cents. And traditionally we have the word either if here, we want that, or sometimes people put when. So it's 50 cents if x is between 0 and 1, including 1. It's 80 cents if x is between 1 and 2, including 2, etc., etc. Now let's use those values to graph the piecewise graph of C on this chart, on this graph here. So it starts at 50 cents, and it's open at 0, and it goes over, and it's a horizontal line, and it does include 1. So notice that we have an open circle on the left and a closed circle on the right. And then same thing here, 80 cents, open on the left, closed on the right, $1.10, and then $1.40. And then finally we can use this graph to find these limits. So the limit as x goes to 3 from the left side would be on this third bar here, and that's going to be $1.10. The limit as x goes to 3 on the right side would be on the fourth bar, coming in from the right side. It's $1.40. And then since these limits differ, the limit as x goes to 3 does not exist. Let's look at questions 12 through 14. The function for each of these is going to be f of x is equal to 2x minus 9, is going to be x squared minus 9x plus 14. Question 12. Find the slope of the secant line of f between the points 2 and f of 2 and 5 and f of 5. So that's just the slope. So it's going to be f of 5 minus f of 2 over 5 minus 2. Using the function, we would get f of 5 is equal to negative 6 rather, and then f of 2 is equal to 0, divide by 3, and that's going to give you negative 2. Question 13, use that function. I'll write the function up here again. It's x squared minus 9x plus 14. Use the definition of derivative with the difference quotient and the limit to find the derivative. So f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. So let me fill that in. That would be the limit as h goes to 0 of x plus h squared minus 9 times x plus h plus 14 minus x squared minus 9x plus 14 over h. Then we need to work out some of this. So x plus h squared is x squared plus 2xh plus h squared minus 9x minus 9h plus 14 minus x squared plus 9x minus 14 all over h. Next, cancel off what you can. So the x squareds cancel, the 9x's cancel, and the 14's cancel. And that leaves us with the limit as h goes to 0 of 2xh plus h squared minus 9h over h From here I can factor out an h. So it's 2x plus h minus 9 over h. The h's cancel. And that leaves me with the limit as h goes to 0 of 2x plus h minus 9. Since we don't have the denominator anymore, we can evaluate when h goes to 0. So it's 2x plus 0 minus 9, which gives me 2x minus 9, which is the derivative of the original function. Lastly, we want to find the slope of the tangent line to f at x equals 2. So we know that the function f prime of x is equal to 2x minus 9. So what we want is f prime of 2, which is 2 times 2 minus 9, which is negative 5. Lastly, we have problem 15. Show that the function f of x is equal to the absolute value of x is not differentiable at x equals 0. This is exactly one of the examples we did in the notes, so I'll let you refer back to your notes for that one. And finally, number 16, sketch the graph with the following sign chart. So I'm going to graph it here, lining it up so the 0 for the y-axis would be somewhere in the middle between -2 and 1. We have a discontinuity at -2, and it's positive on the left and negative on the right. Now there are lots of answers. You could have gone with the vertical asymptote scenario. You can go with the open hole that meets at the origin or at the x-axis. I'm going to do this one. This is one I like here. Sort of positive on the left side here, and then negative on the right side. Open holes because it is undefined at -2. So you can't have any sort of value there at all, even if it's not one of the holes that's filled in. It's undefined. You can't have anything. Then at 1, we have a 0. And a 0 simply means that it goes through the x-axis. So from here, we're going to go up to that. We're not going to cross over, though. We're going to stay down low here and then keep going on this side. You just got to make sure that each of these signs was seen to. The 0 was there, and the -2 was undefined somehow, and you got full credit for this one. All right, thanks for watching this video.